method. Let me recall the formulas we have discussed for the general method. The first formula is if we have a linear factors like yp is equals to, or particular integral is 1 upon phi of d into the right hand side function f of x, which is nothing but if it is in linear factor, that is d minus m is a factor operated on f of x, then how do we operate? It is equals to e to the power mx integration of e to the power minus mx f of x dx, right? The second formula for d plus m factor, yp is equals to 1 upon d plus 1 d plus m f of x is equals to e to the power minus mx integration of e to the power mx f of x dx, isn't it? And the same formula is we are using repeatedly if the equation is of higher order differential equation, right? We have discussed one example also. Shall we have one more example so that we can proceed with the next? Yes, everyone. Hello, am I audible?
Yes, sir.
Yes, sir.
So take next question, that is solve capital D square plus 5d plus 6 the whole times y equals to e to the power minus 2x into sec square x into 1 plus 2 tan x. Okay, d square plus 5d plus 6 into y is equals to e to the power minus 2x sec square x into 1 plus 2 tan x. Clear? So it is already in capital D form. What is its solution? The solution is y equals to, or the dependent variable equals to complementary function plus particular integral, right? What we do to find the complementary function? Yes,
Auxiliary equation.
yeah. To find CF complementary function, let its homogeneous differential equation consider a homogeneous differential equation is nothing but what the right hand side is 0 of the given equation. So that is d square plus 5d plus 6 times y equals to 0. And hence its auxiliary equation is d square plus 5d plus 6 equals to 0. So what are the roots of auxiliary equation? D equals to
Minus
-2,
2, minus
-3.
3.
minus 2 minus 3, which are real and distinct, right? Real, distinct. So what is the formula for the real distinct roots? Complementary function is equal to, yes, any one of you?
C1
C1
e raised to the
e to
power
the power
minus 2x plus C2 into e raised to the power minus 3x.
-3x.
very good. CF is equal to this. Now to find PI, this is a detailed solution. Okay, to find particular integral, first of all we consider the formula. What is the formula? PI equals to, yes, 1 upon
1 upon phi of d
phi of d into
into
the
f
right
of
hand
x.
side function, that
F
is
of x.
function of x. So let us substitute the values. Here the phi of d is given to be d square plus 5d plus 6. We can directly write it into its factored form. As we know, to use the general method, we need the factors, right? So we can directly write, or we can write in next step. What is f of x? F of x is something like e to the power minus 2x into sec square x into 1 plus 2 tan x, right? So we use general method here. So for that we need to write the phi of d in terms of its factor. What are the factors then? D plus 3, d plus 2. into e to the power minus 2x sec square x into 1 plus 2 tan x. So what we do? We operate first of all. See, one more thing I want to tell you that we can operate any one of the factor. Huh? In yesterday's example, also we have operated. Why we have operated this factor? You can ask from your side the questions. So here the operation or order for the operation is not important. We can operate any one of the two operator, but we will select according to the difficulty level of the question, isn't it? If we can see here e to the power minus 2x term is there, isn't it? So it will be easy to operate 1 upon d plus 2 first. Of course, we can apply the d plus 3 also. Then in that case, we have to do some suitable substitutions. Instead of that, we can directly proceed with this 1 upon d plus 2 operated on this. Is this clear? So that is equals to what it will be then d plus 3 into क्या होगा फिर बताओ. It is
e raised
equals
to
to,
power minus
e raised
2x
to 2x
it is
minus
minus, no?
integral of
minus
yes,
2x.
Just a minute, let me take the curly bracket here because the two brackets will be there. E raised to minus 2x into
Integration e
integration of
raised to 2x.
e raised to 2x into f of x, where
E
f of
raised
x
to
is e to the power minus 2x into sec square x into 1 plus 2 tan x dx. Okay, so here e raised to 2x into this will be 1, and how do we evaluate this integration? That is equals
sir,
to
put
1
tan
upon
equals to t.
plus tan x is equal to t, right?
t.
Right. So d plus 3 into e to the power minus 2x integration of sec square x into 1 plus 2 tan x dx. Right. So we can consider the integration separately. Let integration sec square x into 1 plus 2 tan x dx. Put tan x is equals to t. So that will be sec square x dx becomes dt. Am I right? So the substitution becomes, so therefore integration of sec square x into 1 plus 2 tan x dx becomes integration 1 plus 2 t na? And sec square x dx. You can see here sec square x dx. So here this sec square x and into this dx becomes dt. So how much it is? It is equals to t plus t square. Am I right? Is it
Yes.
t plus t square? So let us substitute the value of t, that is tan x plus tan square x. So this is the value of integration. Let us substitute into the last step, and hence the particular integral is, therefore pi equals to 1 upon d plus 3. I hope everyone is doing along with me. 1 upon d plus 3 into e to the power minus 2x into integration, right? So what is integration? Tan x plus tan square x. Check. Okay, into this integration we have substituted. Now what? Again apply 1 upon d plus t, 1 upon d plus 3 onto this f of x. So what it will be? E to the power minus 3x integration of e to the power 3x into f of x, where f of x is e to the power minus 2x into tan x plus tan square x dx, right? So that is equals to e to the power minus 3x integration of e to the power x into tan x plus uh, tan square x dx. How do we solve this now? How do we solve this integration? What to do?
X square x minus 1 is equal to.
Yeah, the formula for tan x, right? In terms of
Yes.
sec.
Tan square x is equal to
This x square x
Sec
minus.
square x minus 1, right? So e to the power minus 3x integration of e raised to x into, I can write tan x plus sec square x minus 1. So that is equals to e to the power minus 3x integration of e to the power x into I can add just like this, tan x minus 1 plus sec square x. Can I write like this so that I can
Yes.
substitute? So if I substitute for tan x minus 1 is equal to t, then the derivative of tan x minus 1 is what? Sec square x, right? So this is here we are going to apply this formula. What the formula is? Formula integration of e to the power x into f of x say plus f dash of x, right? You might have
E
used this
raised to
formula,
x
that
f
is
of
equals to
x.
e to the power x f of x, no?
f of x.
F
Yes.
of x. So using this formula, we directly get the last answer. What is that? So therefore, pi equals to e to the power minus 3x into
E raised to
e
x
to the
tan
power
x
x
minus
into
1.
f of x, that is tan x minus 1. That is your last value of particular integral, and hence therefore the general solution, or it is also called complete solution, and that is y equals to cf plus pi, that is c1 e to the power minus 2x plus c2 e to the power minus 3x plus e to the power minus 2x into tan x minus 1. Am I right? I have combined these two terms. Is this okay to everyone?
Yes, sir.
Yes,
And
sir.
that is your last complete solution. Please ask if any doubt. It's very easy and straightforward, but a little bit lengthier one because of these integrations. So if you are confident about the integrations, techniques of integrations, then this method, general method, will be easy for you. Is it okay? Shall we have one more?
Yes, sir.
Write down. Solve d square minus 1 times y equals to e to the power minus x sine of e to the power minus x plus cos of e to the power minus x. Okay, it's 1:55. I'm giving you 3 minutes. Everyone, solve quickly as much as we can. Do it fast, everyone. So we can directly see here what are the roots of its auxiliary equation to find the complementary function. I can directly
Plus
write
or
the
minus
Plus
1.
or
Plus or
minus
minus
1.
yeah
1.
Plus or
plus
minus
minus.
1.
So the roots are plus minus 1, which are real and distinct, and hence the complementary function is c1 e to the power minus x plus c2 e to the power plus x. Is the screen visible?
Sir, the screen is black, sir.
Yeah, that is what I actually also unable to see the screen. Let me share again. Actually, my PC is getting hang. Is this visible now?
Yes, sir.
So everyone, please do it fast. Particular integral. Hello, is there anyone who got the last answer or the
Yes, sir.
particular integral? What is that?
Yes, sir. Minus e raised to x, sine e raised to minus x.
Very good. Minus e to the power minus x into sine of e to the power minus x is the particular integral. Okay, so I'm also trying. It is e to the power x minus x integration of e to the power x e to the power minus x sine of plus cos of e to the power minus x dx. Actually, it is minus here, no? And the plus inside. It's not plus here. So 1 upon d minus 1 e to the power minus x. And how do we solve? Actually, here also the same formula we can use. If I substitute for, I think cos x, right? Cos of this is equal to t. Then its derivative will be this, na? Is it?
Yes, sir.
Hello? You just check. You'll get this is suppose f of t. Then this is f dash of t or f dash of x. So we know the formula, it is equals to what? E to the power x into f of x, that is cos of e to the power minus x, and that is equals to 1 upon d minus 1 cos of e to the power minus x. So now I apply the second operator, that is e to the power x, integration of e to the power minus x f of x, and when I substitute for e raised to minus x is equal to t minus e raised to minus x, so minus will be outside, e raised to minus x dx will be dt, so cos t dt, so that is minus e to the power x into integration of cos t is sin t, and that is equals to minus e raised to x into sine of e to the power minus x. So hence the last complete solution is CF plus PI. Please write the solution. I'm not going to write. I hope now everyone is clear about this general method. Is there anyone who is still having doubt? Please ask if any. Is this clear to everyone?
Yes, sir.
Yes, sir.
Yes, sir.
Good. Okay. So let me give now one note for this method. You can write there note for the general method specially. This method is used. This method is generally used when f of x is a composite function or a rational function or inverse trigonometric function, etc. Okay, actually, as it is general, we can use this method to any exam of linear differential equation of first order, first degree. But we still are going to discuss the shortcuts to get the particular integral. So, as this is lengthier one, if the f of x is composite or any rational function or inverse trigonometric function, etc., then we directly go to the general method because we don't have any shortcut for such functions. This f of x is the right hand side functions in the given linear differential equation. Is this clear to everyone? Hello?
Yes, sir.
Yeah. So now the next is shortcut method. Now, what is shortcut method? So to find the particular integral, of this linear differential equation of first order, sorry, linear differential equation with constant coefficient, that is phi of d into y is equal to f of x. As we have seen, the general method is little bit lengthier, and to those who are not confident about solving the integrations, isn't it? So for them, we can have a shortcut. But again, the shortcut method is a restricted one. So if the right hand side function, this function is of special type, then only we can have the shortcuts to those. So there are 6 to 7 different forms of this f of x, and based on the nature of this right hand side function, we can have the shortcuts. Like for example, if this f of x is exponential function of the form e to the power ax, then we can directly have a shortcut. Instead of evaluating those integrals by general method, we can directly have a shortcut for this exponential function. Or if it is a trigonometric function, especially sine and cos, sine of ax plus b or cos of ax plus b, then we have shortcut. Okay, or if it is a hyperbolic functions like sine hyperbolic ax plus b or hyperbolic cos ax plus b, or if it is a polynomial function of the form x raised to m, where x is independent variable. Okay, so if this f of x is a polynomial function, then also we have a shortcut. Now from fifth onward, it is related to the composite function. If f of x is a composite function of the form uh, e to the power ax exponential into v, where this v is any of the function among these three. Okay, where v is a function of x among these, sine or cos or hyperbolic sine or cos or a polynomial function. We have a shortcut when fx is a product of x into v, where v is the same, v is a function of x. So here the power of x must be 1. Remember, if the power of x is not 1, then we cannot use this method. Okay, now the seventh method we are having, or seventh case we can say, if that f of x is x square into sine of ax or x square, instead of x square let me write x raised to m, because power can be anything, x raised to m sine ax or x raised to m cos ax. So these are 7 different shortcuts we are having to these special functions. So let us discuss one by one. Case 1. When f of x is e to the power ax. So what we are trying to find? Yes, what actually we are discussing here? The methods to find? Yes, methods to find. Hello, I'm asking to you peoples. Hello. Okay, we are discussing here the methods to find the particular integral. I think you might not be getting my question. So particular integral is 1 upon phi of d into the right hand side function, right? F of x. So here when we substitute f of x here, 1 upon phi of d into e to the power ax. So it will be depends on us now whether to proceed with the general method or the shortcut method. So let us discuss first of all what is shortcut method. So let me explain here. As we know, d means what? Yes, what is mean by d? Capital D. What is the meaning of d here?
d by dx.
D is the derivative with respect to x, right? So what is the derivative of e to the power ax here? It is a e to the power ax, right? Similarly, if I operate one more d, that is d square. D square of e to the power ax is what? The double
A
derivative of e to the
square.
power x, isn't it? That is the derivative of d of e to the power ax. That is d of a e to the power ax, and that is d square.
Square.
What is that? It is square, no? A square e to the power ax. Am I right? So what I'm trying to show, d square of e to the power ax is a square of e to the power ax. Now what if it is d cube? It will be
A cube e
a cube
raised to
of e to the
ax.
power ax. So can you generalize now it? Can you generalize this? D raised to n.
Dn
D raised to m
a to
It
ax
is a
am
to the power n e to the power
e raised to
ax.
ax.
Right? Now, as the powers of, just a minute. As the powers of d, when we operate on exponential function, we are getting the powers of a, same powers. Is it? So as like the powers of d, if I take a function of d like 1 plus d, then that will be 1 plus a, right, of the form. So what I'm trying to show, phi of d, function of d operated on e raised to ax will be what? It will be, yes, what will be on the right hand side? Hello, this is a function of d, na, d raised to n, d cube, d square.
a raised to n, sir. A raised to n into e raised to ax.
No, no. So function, whatever the function of d, when I operate onto e raised to ax, what I'll be getting here, it will be a function of a, na?
Yes, sir.
Is it? So when I take these two terms uh, in a cross manner like this, that is 1 upon phi of a, if I take here e to the power ax, and 1 upon phi of d to the right hand side operated on e raised to x, then this will gives me the formula or the pattern. Is this clear? So from this, what we can write here, it will be equals to 1 upon, yes,
Phi of A.
phi
Phi of
of a
a
e to the power ax.
ax.
So this is what the formula is. That's it. But provided that this denominator must be, yes, it must be
Not equal
Not
to
equal
0.
to
non-zero. ठीक है? For example, see here. For example, uh, d, say d cube plus d plus 2 into y is equals to, say, e to the power 2x. So directly we can get its particular integral, that is equals to 1 upon d cube plus d plus 2 operator e to the power 2x is equals to what? We need to replace, what this means, we are replacing this d by a.
A
So just replace d by a. What we'll get here? 2 cube plus 2 plus 2. So what the answer is? 8 plus, that is 12, no? So that is your particular integral. Isn't it the easy? If we compare it with the general, it's very easy actually, isn't it? So now you can ask the question, what if the denominator is zero? Denominator can be zero, no? It is not possible all the time that denominator is non-zero. We can have the functions like say d minus 1, d plus 2 into e to the power minus 2x. Can we can have such functions also, right? So if I replace d by what, what is the value of a
minus
here?
2.
Minus 2. So if I replace d by minus 2, phi of d is 0, phi of minus 2 is 0, right? So
Yes,
what
sir.
do I do? What if we have such cases? So in that case, we have the next, that is writing here, if phi of a equal to 0, then it is called a case of failure. Case of failure. And hence, therefore, particular integral will be equals to 1 upon phi of d e to the power ax can be written as, it can be written as x into 1 upon phi dash at a derivative of function with derivative of this phi, and then into that replace d by a e to the power ax. So for this we have a keyword here. We are replacing simply d by a, replacing d by a. Is this clear to everyone? Here also provided that this phi dash of d must be non-zero. Is it okay? So ऐसे ही करते जाना है आपको. If you are getting zero denominator, then we have to multiply that operator by independent variable. This is independent variable, remember. So let me write once again. If phi dash at a is equal to 0, then what the particular integral will be? Pi is equals to 1 upon phi of d e to the power ax will be equals to what? This is already x and one more x will be there, so that is equals to x into x, that is x square 1 upon the derivative of phi dash, that is phi double dash of d, and into that replace d by a, so that is phi double dash at a e to the power ax. Is this clear to everyone?
Yes, sir.
And
Yes,
so
sir.
on. So this is and so on. Now we are having some sub cases of this exponential function. First sub case is when fx is an exponential function of this form a to the power x. First of all, tell me, is it exponential function? Always remember, when the variable is in power, then that becomes an exponential function. Always. It is not necessary that exponential function is of the form e only. It can be exponential function. Okay. So I can write this a raised to x in terms of e. How do I write? Yes. Can I write like this? E to the power log of a to the power x. Can I write like this?
Yes, sir.
Will it be
Yes,
same?
sir.
Yes. So
Yes, sir.
it will becomes then by using the laws of indices, or sorry, not laws, the properties of log. But I'll be getting here e to the power x into log a. Am I right? So that is nothing but e to the power capital AX, where capital A is what?
Constant.
Log a, right? Constant. So why I've written in this form? Because I know for e to the power ax case, what I'll have to do, I'll just have to replace d by a. So the particular integral of 1 upon phi of d a to the power x will be equals to 1 upon phi of d e to the power x into
Capital.
log a, that is, or a capital ax, and that will become what? 1 upon phi at capital A, or uh, phi at log a into e to the power x log a. Is this clear to everyone? Where
Yes,
provided
sir.
that phi of log a must be non-zero. If it is zero, then we'll have to do the same thing, just like the above we have discussed. Please ask if any doubt. Is it clear? So actually, we can directly write this as a. Oh, sorry, I've added the page in between. That is my mistake. Anyways, So here it will be 1 upon pi of log a into a to the power x only, right? Because this is nothing but a raised to x only. So this is your particular integral in this case. So for example, if the fx is of this form 2 raised to x, 3 raised to x, or 1 upon 2 to the power x, or 1 upon 2 raised to x. Clear? So for these functions we can use this rule, sub case. Is this clear? Any doubt?
No, sir.
Okay. So now second case, case number 2, what it says, when fx is an exponential function of this form a to the power minus x. Now can you tell me how do I write this as a, or what will be the replacement here? Is this okay? The same thing like the previous one. We have written a raised to minus x in terms of exponential, and then we have replaced d by minus log a. Is this okay?
Yes, sir.
The second. Now the same thing, huh? Here also the denominator must be non-zero. Phi of minus log a must be non-zero. If it is zero, then what we'll do? We will multiply this operator by the independent variable, this operator by the independent variable, into the derivative of denominator at a. Okay? Now the third case, case number 3, sub case number 3. If fx is a constant function, any constant function k, then can I write that constant in terms of exponential? Or can I write like this, k e to the power 0x?
Yes, sir.
Yes.
So therefore, pi is equals to 1 upon phi of d into k operated on k will be equals to what? 1 upon phi of d operated on k e to the power 0x. But as we know, this is integrating operator. This 1 upon phi of d is an integrating operator. We can write constant outside the integration. So it will be 1 upon phi of d e to the power 0x. And what we do in case of e raised to 0x? Yes, we replace d by 0, right? So this will be a particular integral in case of fx to be a constant function. Clear? Clear है सबको? Is
Yes,
this
sir.
okay? Just take a look over the method we are discussing. Okay. Now let us have some formulas. Formula number 1. 1 upon d 1 upon d minus a raised to r e to the power ax will be equals to. So what do you think? How many times this term or this factor will be of case of failure, d minus a raised to r? How many times it will be a case of failure? Hello, are you getting my question? How many times this operator will be a case of failure?
Sir, R times.
R times it will be a case of failure, right? So it is not, suppose if that R is much large, then that is not manually possible, isn't it? To get the particular integral by successively differentiating that phi of d. So instead of that, I have a formula for this. It will be directly equals to written as x raised to r upon r factorial e to the power ax. Is this clear? Is this clear to everyone? For example, if I have 1 upon say d plus 2 raised to 10 e to the power minus 2x. So I know here minus 2, if I take the derivative, if I first of all if I just replace this d by minus 2, it will be 0, is it? So in that case I know that I'm multiplying by independent variable into, I'm taking the derivative of denominator. So what the derivative is, it will be 10 into d plus 2 raised to 9, right, into e raised to minus 2x. But again when I replace, it will be a case of failure. Are you getting what the problem is, what I'm trying to show, isn't it? So we have to differentiate 10 times, then we'll be getting finally the non-zero denominator. Hello, is the point clear to everyone, isn't it? So
Yes,
this
sir.
formula is very much useful in that case. Now the question is, sometimes suppose in this case 1 upon say psi of d into say d minus a raised to r e to the power ax, where psi of d is that function who don't have any problem at a, which is not 0 at a. Can we have such factors? You can see here, I'm explaining. The question can be like this, or the phi of d can be like this: d plus 2 into say d minus 4 the whole square into e to the power 4x. Can we have phi of d like this? We can have, no? Right? So here, which is the problematic factor? This one, right? This, we don't have any problem to this factor. We can directly replace d by 4. Are you getting my point? So in this case, the formula is, use the formula, use the previous formula to the problematic factor and use the case to the non-problematic factor. What is the case? Replace d by a. So it will be equals to 1 upon psi at a x raised to r upon r factorial e to the power ax. Is this clear to everyone? The formula. Hello.
Yes, sir.
Yes, sir.
Let's have one example. Right on. Solve